Hello everyone, this is Vijayalakshmi Sugnali from WinMaths YouTube channel. Here, WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and some various competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation well for various examination. Okay, here in this session, we have to discuss the continuation of the exercise problems 1.1 on the concept relations and functions. Okay, one question number one and some of the questions already discussed in previous class. Now let us discuss the second question. Show that the relation R in the set of real numbers defined as R is equal to A comma B such that A is less than or is equal to B square is neither reflexive nor symmetric nor transitive. Okay, we have to check the condition reflexive, symmetric and transitive, but here reflexive, symmetric and transitive conditions are not satisfied. So we have to prove the or else we have to satisfy the condition reflexive, symmetric and transitive. Okay. Now I will take the relation R is equal to A comma B such that A is less than or is equal to B square. Okay. Now first condition checking the reflexive condition. Okay. Here reflexive for every A which is belongs to real number R. So A comma A not belongs to R. Okay. The relation A comma A not belongs to R because here I will consider any one example. Okay. Example 1 comma 1. Okay. 1 comma 1. So the relation 1 is less than or is equal to 1 square. Okay. Now, is it 1 is less than or is equal to 1? Yes, it is true. But similarly, I will consider 1 by 2, comma 1 by 2. Okay. Now, here A is 1 by 2, then B square less than or is equal to 1 by 2 whole square. Okay. Then 1 by 2 here less than or is equal to what is the value of 1 by 2? 1 by 4. Okay. 1 by 2 is not equals to 1 by 4 and also 1 by 2 is greater than the 1.1 by 4. So some of the numbers satisfy not satisfy the reflexive relation. Okay. Therefore, R is not a reflexive. Okay. R is not reflexive. Similarly, I will check the condition symmetry. Okay. According to the definition of symmetric, if A comma B belongs to R, then B comma A is also belongs to R. Now, check the condition. Let us consider an example. I will consider one example 1 comma 2. Okay, 1 comma 2 belongs to the relation. That is 1 is less than or is equal to 2 square. Yes, this is possible because 1 is less than the 4. The condition satisfied. Again, similarly, if 1 comma 2 belongs to R, then 2 comma 1 is also belongs to R. That time the condition will satisfy. Okay. Here 2 comma 1 is also belongs to the real number. So 2 is less than or is equal to 1 square. No. 2 is not less than or is equal to 1. Okay. Not less than or is equal to 1. So condition not satisfied because 2 is the greater than 1. Therefore, R is not symmetric. Next, again, I will check the condition Third one, transitive. Okay. Here, according to the definition of transitive, if A comma B belongs to R and B comma C belongs to R, then the first element is related to third element, that is A comma C is also belongs to R. This is the definition of transitivity. Now I will check the condition while taking the example. Okay. If they given in the question show that, so we have to show. So I will take directly one example, that is A is equal to 2, B is equal to minus 2 and C is equal to minus 5. Okay, these are the three numbers. Now first, if 2 comma minus 2 belongs to R, okay, then I will check the condition. 2 is less than or is equal to minus 2 square. Okay, 2 is less than or is equal to 4. The condition satisfied here. Again, the second number is related to third. Minus 2 is this, comma minus 1 belongs to R because minus 2 minus 1 is also real numbers. Here, minus 2 is less than or is equal to minus 1 whole square. So minus 2 is less than or is equal to plus 1. Yes, minus 2 is less than or is equal to plus 1. Then the condition satisfied. If A is related to B, then B is related to C. Obviously, the third one, we will check the condition here. 2 comma minus 1 belongs to R. Okay, here 2 less than or is equal to minus 1 whole square. Okay, here 2 less than or is equal to 1 square, that is 1. Is it true? No, 2 is not less than 1. So, which is not. The condition not satisfied. Therefore, R is neither reflexive, neither reflexive nor symmetric nor transitive. This is the proof of the given problem. Okay. Now let us move on the next question. Question number 3. Check whether the relation R is defined in the set 1, 2, 3, 4, 5, 6. The set containing the elements 1, 2, 3, 4, 5, 6 as the relation R satisfy the condition B is equal to A plus 1 is reflexive, symmetric or transitive. Okay, we have to check the condition here. The first condition, before that I will take the set. A be a set containing the elements 1, 2, 3, 4, 5, 6. And based on the elements, I will write the relation. Okay. So directly I will substitute the values here. I will take A is equal to 1. Then B value 1 plus 1, it is 2. Similarly for 2, B value 3. 3 comma 4, 4 comma 5, 5 comma 6. Then 6 comma 7. These are the order pairs of the given relation. Okay. Whatever the values of A. Here 1, 2, 3, 4, 5, 6. We get the values of B. Based on the relation, we have to check the condition. First one, reflexive condition. Okay. Here, if 1 comma 1 not belongs to R, 2 comma 2 not belongs to R, up to so on for 6 comma 6 not belongs to R. Okay. Therefore, it is not reflexive. Simply, their images are not present. Okay. If an element and their images are not present in the relation, that's why it is not reflexive. Similarly, I will check the condition symmetric. If a relation containing the order pair 1, comma 2, which is belongs to R, but 2, comma 1 not belongs to R. 2, comma 1 not belongs to R. For every 1, 2 belongs to the set A. Okay. Here 1, comma 2 belongs to R, but 2, comma 1 not belongs to R. Therefore, it is not symmetric. Then third condition, transitive. Okay. Now, let the first order pair 1, comma 2 belongs to R. Okay. And also 2, comma 3 belongs to R. But here the first element is related to second and second element is related to third. Then 1 is related to 3, not present. According to the definition, A is related to B, B is related to C. Then A is related to C. But here this condition not satisfied. For every elements 1, 2, 3 belongs to set A. Therefore, it is not transitive. Okay. It is not transitive. Therefore, what we have written, the relation are neither reflexive nor symmetric, neither reflexive nor symmetric nor transitive. Neither reflexive nor symmetric nor transitive. Okay. To this much, the question number 3 is okay. Then consider the question number 4. Show that the relation R in R defined as. Okay. There is a relation R is equal to the order pair A comma B such that A is less than or is equal to B is reflexive and transitive but not symmetric. Okay. We have to take some example. Based on the example, we have to prove the condition or relation satisfy reflexive and transitive but not a symmetric. Okay. Here, first I will consider the relation R is equal to A comma B such that A is less than or is equal to B. Okay. Now check the condition one by one. First one is reflex. Okay. Here, let an element A comma A belongs to R. Yes. Okay. By the definition, A comma A belongs to R. Now consider an example. 1 comma 1 belongs to R. Is it true? Yes. Because here there is a condition 1 is less than or is equal to 1. Yes. 1 is less than or is equal to means almost 1 is equal to 1. Okay. This condition satisfied for 1 is belongs to R. Similarly, for every A comma B belongs to no. Therefore, it is reflexive. And again, second condition, symmetric. Symmetric. Okay. Let according to the definition of the symmetric property, A comma B belongs to R, then B comma A also belongs to R. Okay. Here I will consider one example. No, 1 comma 2. Okay. 1 comma 2 belongs to the relation. Then I will consider the condition. 1 is less than or is equal to 2. Yes, the condition satisfied because 1 is less than 2. Similarly, 2 comma 1 belongs to R. Check. Here, 2 comma 1. Then 2 is less than or is equal to 1. 2 is greater than 1. Okay. But here the condition denotes 2 is less than or is equal to 1. The condition not satisfied. Okay. Here the condition not satisfied. Therefore, 1 comma 2 belongs to R, but 2 comma 1 not belongs to R. Therefore, it is not symmetric. It is not symmetric. Okay. Now, again, I will check the condition 3. That is transitive. Now, let, according to the definition of transitivity, let A comma B belongs to R and B comma C belongs to R. But then first element A comma C is also belongs to R for every A, B, C belongs to the set of real number R. Okay, this is the definition of transitive. Again, I will check the transitive condition for take A is equal to 1, B is equal to 2, C is equal to 3. Okay, now let us consider the condition here. 1 comma 2 belongs to R. Okay, then the condition 1 is less than or is equal to B. Yes, 1 is less than or is equal to B, that is 2. Okay, 1 is less than or is equal to 2. Yes, it is less than 2. The condition satisfied. Again, 2 comma 3 belongs to R. That is 2 is also less than or is equal to 3. Yes, condition satisfied. Then the first element is 1 comma 3 belongs to R. Okay, here 1 is also less than or is equal to 3. Then the condition will be satisfied. Therefore, what we written? 1 comma 2 belongs to R and 2 comma 3 belongs to R. Then obviously 1 comma 3 is also belongs to R. Therefore, R is reflexive, transitive, but not symmetric. Okay, but not symmetric. Hence the solution of the given problem. Next, let us move on the next question. Question number 5. Check whether the relation R in R defined by the relation A comma B is A comma B such that A is less than or is equal to B cube is reflexive, symmetric or transitive. Okay. Here we have to check the condition reflexive, symmetric, as well as transitive. Okay, we have to check the condition here. First, I will take the relation A comma B. Okay, I will consider the relation R, that is order pair A comma B, such that A is less than or is equal to B cube. Okay, now I will check condition one by one. Reflexive. Okay, here R is the set of real numbers. So both A and B are the real numbers. Okay. Now condition, if A comma A belongs to R, then A is belongs to the real. Okay. Then I will take one example. 1 comma 1 belongs to R. Yes. Obviously the condition satisfies because 1 is less than or is equal to 1 cube. It means 1 is less than or is equal to 1. The condition satisfied. Similarly, I will take 2 comma 2 belongs to R. Okay. Now 2 is less than or is equal to 2 cube. What is the value of 2 cube? 2 is less than or is equal to 2 cube. That is 8. 2 is also less than 8. Yes, the condition satisfied. Similarly, I will take 1 by 2, 1 by 2. Okay, belongs to R. Now, 1 by 2 is less than or is equal to 1 by 2 cube. Then, 1 by 2 is less than or is equal to 1 by 8. It is true? No. 1 by 2 is greater than the 1 by 8. Okay. 1 by 2 is greater than the 1 by 8. That's why this condition is not satisfied. Therefore, R is not reflexive. R is not reflexive. Now, I will check the second condition, symmetric. If A comma B, according to the definition, if A comma B belongs to R and B comma A is also belongs to R. For every A comma B belongs to the set of real numbers, then the condition satisfied. Okay, if these conditions satisfy, then we will check the example. Let I will consider one example here, that is 1 comma 2. Okay, 1 comma 2 belongs to R. Then condition, 1 is less than or is equal to 2 cube. Obviously, because 1 is less than or is equal to 8. Okay. Similarly, 2 comma 1 belongs to R. Here, 2 is less than or is equal to 1 cube. 2 is less than or is equal to 1 cube. The condition not satisfied here. Therefore, 1 comma 2 belongs to R, but 2 comma 1 not belongs to R. For every 1 comma 2 belongs to the real numbers. Okay. Therefore, R is not symmetric. R is not symmetric. Similarly, I will check the condition transitivity. Okay. Here, I will check the condition transitivity or transitive. According to the definition, if A comma B belongs to a real number, relation R, then B comma C belongs to the relation R, then obviously it implies A comma C is also belongs to R. For every A, B, C belongs to R. Okay, this is the definition. Now, I will check the examples here. Then, considering the elements, A is equal to 3, B is equal to 3 by 2, and C is equal to 4 by 3. Okay, because you have to take any example here. Okay, but actually all the examples satisfy. But while checking the definition, we will take any counter example. Okay, here first condition, if an element 3 comma 3 by 2. Okay, the condition 3 is less than or is equal to 3 by 2. Okay, 3 is less than or is equal to 3 by 2 cube. Okay, 3 is less than or is equal to, what is the value of 3 by 2? That is 3 by 2 means 1.5. 1.5 cube is equal to 3.37 something. Okay, which is greater than 3. The condition satisfied. Similarly for 3 by 2, comma 4 by 3. Okay. Now, here also the condition satisfied. 3 by 2 is less than or is equal to 4 by 3 whole cube. Okay. That is 3 by 2. What is the value of 4 by 3 whole cube? 4 by 3 whole cube becomes 2.37. 2.37. Okay. Which is not satisfied. The condition not satisfied here. Okay, 3 by 2 is not greater than. Similarly, for first element, 4 divided by 3. Okay, while taking 3 is not less than or is equal to 4 by 3 cube. Okay, the condition not satisfied. Therefore, R is not reflexive, not symmetric, not transitive. Okay. Now, let us move on the next question. Question number 6. Show that the relation R in the set 1, 2, 3 given by the relation 1, 2, 2, 1 is symmetric but neither reflexive nor transitive. Okay. Simply we have to take the relation R is equal to 1, 2 and 2, 1. Okay. Here, first reflexive condition. Okay. 1, 1 not belongs to R. Let 1, 1 not belongs to R. 2, 2 not belongs to R. 3, 3 not belongs to R. Okay. But 1, 2, 3 R belongs to a set A. Okay. Therefore, it is not reflexive. It is not reflexive. Second one, that is symmetric. Let relation 1 comma 2 belongs to R and 2 comma 1 belongs to, okay. Therefore, for every 1 comma 2 is also belongs to any set A. Therefore, it is symmetric. Okay, it is symmetric. Similarly, I will check the relation transitive here. Let 1 comma 2 belongs to R and 2 comma 1 an element, this is also belongs to R, but 1 comma 1 not belongs to R. For every element of 1, 2 belongs to the set A. Therefore, R is not transitive. Okay. Finally, therefore, R is symmetric but neither reflexive nor transitive. Neither reflexive nor transitive. Okay. This is the proof of the given problem. Now, let us consider the question number 7. Show that the relation R in the set A of all the books in a library of a college. Okay, here we have to consider A is a set containing the all the books in a library. Set A. All the books in a library. All the books in a library. Okay. Then again, there is a relation R such that x comma x and y have the same number of pages. X and y have same number of pages. Okay, this is the relation. Now, check the condition one by one. First one, reflexive. Let, according to the definition, A comma A belongs to R. Here, I will consider any one book. Okay. Here X be any book. Okay. X be any book. Then X is related to X. Yes. If in a library so many books are there, the book is related to the same book also. Yes. For every books. Okay. For every X belongs to the set A. I will consider X be any book. Similarly, the same type of books are there in that library. That's why the relation is satisfied. Okay. That is for every X belongs to A. Again, I will take the second one relation symmetric. Okay. Then, according to the definition of symmetric, let A comma B belongs to R and B comma E is also belongs to R. Okay. Now, check the condition here. Let X be a book. Okay. And Y is also same book. X and Y have the same number of pages. Yes. X and Y are the two books having the same number of pages which is present in a library. Yes, of course, the relation exists. Similarly, if I consider same book, Y comma X, X comma Y, X is any book and Y is any book, both book having same number, of course, Y comma X, then consider this time also the same books containing same number. Therefore, for every x comma y belongs to a set A containing the same number of books. Okay. Therefore, it is symmetric. Now, I will take the third one condition, that is transitive condition. I will consider third one condition is transitive condition. Okay. Here, according to the definition, A comma B belongs to R. Okay. Then B comma C belongs to R. Of course, A is related to C. Okay. This is the condition of transitivity. Here, I will consider X and Y be any books in a library. Okay. X and Y, any book in a library having the same number of pages, yes, it is belongs to R. Similarly, I will consider another one book Y and also Z be any book. Here Y and Z having the same number of pages, okay, which is also belongs to the relation R. Then if X and Y are same pages and Y and Z are same pages, then of course X and Z are also the books having the same number of pages for every books X, Y, Z in a library. Okay. Then the condition also satisfied. Therefore, it is transitive. Okay. Therefore, a relation satisfies the conditions, satisfy the conditions for reflexive, symmetric, symmetric and transitive. Okay. This is the solution of the given problem. Now, let us move on the next one question. Question number 8. Okay. Show that the relation R in a set A containing the elements 1, 2, 3, 4. Okay. Here I will consider the set A be a set containing the elements 1, 2, 3, 4, 5. Okay. Given by the relation R is equal to A comma B such that mod of A minus B is an even number. Mod of A minus B is an even. Okay. Now, I will consider the relation here, that is 1 minus 1. 0. 0 is an even number. Yes. 1 minus 2. Okay. 1 minus 2. That is odd. 1 minus 3. Yes. While taking 1 minus 3, it is even. Again, 3 minus 1, it is also even number. Then 1 is 1 comma 4 odd. 1 comma 5, it is even. Similarly, for 5 comma 1 is also even number. And 2 4. Okay, 2 4 is also even. 4 comma 2 is also even. Similarly, for 3 and 5. 3 5 is also even. 5 comma 3 is also even. Okay, these are the relations satisfy the above condition. Okay, now I will check the condition, that is first one reflexive. Okay, according to the relation reflexive. Here in the order pair every element, okay, 2 comma 2, 3, 3, 4, 4, 5, 5. These are also getting even numbers. Okay. Here 1, 1 belongs to R. Yes. 2, 2 belongs to R. Up to so on for 5, 5 belongs to R. Okay. Here I will take the definition relation R. Okay. Then A belongs to R. Okay. A relation exists here. That is A belongs to R. For every an element A which is present in set A. Okay. Then it is reflexive. Similarly, for second condition, symmetric. Okay. For symmetric condition, I will check here. Let A, B belongs to A. Okay. The condition mod of A minus B is even. Similarly, for B minus A belongs to R. I can take minus as a common in the bracket, that is B minus A is also even. Yes, both the condition satisfies. Therefore, R is symmetric. Similarly, for transitive condition, let A, B belongs to R. Okay. A, B belongs to R such that mod of A minus B is even. Okay. It is clear. Similarly, for considering the element B, C which is belongs to R, then the condition B minus C is also even. Okay. After combining the two relation, that is A minus B plus B minus C. Okay. That is A minus B plus minus C. Okay. Plus minus get cancelled. Then A minus C is also an even number. That is A minus C is even. Therefore, it is transitive. It is transitive. Therefore, the given relation satisfies all the conditions. That is reflexive, symmetric and transitive. Symmetric and transitive. Okay. Now, question number 9. I will solve the question number 9 in next session. Up to this much, I will solve the questions of exercise problem from 2 to 8. If you really like my classes, please share, like and subscribe my channel. Thank you. Thank you for watching my classes. Thank you everyone.